Thank you very much for coming. My name is Nikita Shamganov. I'm the CEO of MemSQL. And today we're going to talk about real-time image recognition. And so before we talk about infrastructure, let's just talk about the future of computing. And the future of computing is visual. It's also numerical, right? Because at the end of the day, it's zeros and ones are powering those systems. It's intelligent. You can take an iPhone or a smartphone, point at something at a store, and it will give you all the tags and recognize all the tags in real time. We can have things like Snapchat spectacles that you can put, and then will augment the reality that you're seeing through them. And you also do some crazy things such as facial recognition, which is part of the new iPhone 10. So how do you do that? How would you go and implement real-time facial recognition or real-time image recognition? So here's an example of an app, and that's one of the MemSQL customers. What they do here is they point an app at a physical item. Should it be sunglasses or should it be a camera? And then in real time, within a few milliseconds, they recognize and find similar item in the vast catalog of millions of products. And then in real time, they're able to go and detect what that is. Another example of using exact same technology is a nonprofit Thorn. So Thorn's mission is to find missing children. And what they do is they crawl the dark web, finding all the abused children on the internet. Basically, crawling child porn. And then they collaborate with the police. And if there's a missing kid, parents can bring a picture of their child or a set of pictures of their child to the police, and using that system that Thorn developed that runs on top of MemSQL, they can find missing children pretty much immediately. So here are the stats, and we are very proud to support the nonprofit with the technology that we create. So anyway, so how does it work? So we as I'm flipping through the slides, we take a picture of a child, and then we apply a deep learning model, which converts that picture to a feature vector. And then there's a lot of intelligence and there's a lot of training goes into building that deep learning framework. But once you have it and you need to operationalize it, the actual computation is relatively straightforward, and it's a vector multiplication. What happens is you extract about 5,000 features out of each person's face, and then in order for you to see the distance between, kind of the image distance between the two faces, you just need to run a dot product of two feature vectors. And if the closer the product is to 1, the more probability there is that this is actually a match. So in the database terms, if you want to find a face in a database of all the faces, all you need to do is to extract that feature vector from all the faces in the database. You can probably store them separately in a separate table, and then run a command that will run dot product on each face, and then choose those that cross a certain thresholds, say 0.99. So does that make sense? Cool. So if you go to Thorn and look at their infrastructure, they certainly use Spark, TensorFlow, and Gluon, which is a library that it's open source, you can download it on the internet. And then they go and create a table in MemSQL. and the table is called features. The table has an ID, and then it has a feature vector. That image binary 496 is that feature vector. Then there's a little bit of syntax in MemSQL that says you're going to store this table in a Columnstore format, which means it's going to be compressed. It's going to be sitting on disk, and it's going to be cached in memory when needed. And then in order for you to find all the IDs of faces that are similar to the input, you need to extract the feature vector from the input and then just run this simple command. Select ID from features where dot product is greater than 0.9. So once you do the hard work of training the model, operationalizing the model, a deep learning model is actually quite straightforward. So, what is a dot product? Dot product is just a sum of multiplications of specific elements of each vector. So if one vector is A1, A2, A3, and the other one B1, B2, B3, dot product is A1 multiplied by B1 plus A2 multiplied by B2 plus A3 multiplied by B3, etc. However data points you might have. So now we all know that that deep learning and GPUs, they go well together. And the reason to that is when we build those deep learning models, you evaluate dot product, you evaluate all sorts of matrix multiplications. So dot product is a one-dimensional operation. You can do matrix dot product is going to be two-dimensional multiplication. And everything that's above 2 dimensions, it's called a tensor. And tensor multiplication is, you can generalize dot product to tensor multiplication. So now GPUs are very, very good at tensor multiplication. And when you train models, that's what you do. You perform a lot of dot products. Now, when you operationalize stuff, you actually don't need the power of a GPU. And if you implement dot product well, using the latest and greatest technology from Intel, which existed for a few years, but they keep making it better. That's called SIMD. Who's familiar with SIMD? A few people in the room. You can perform a lot of computation at the memory bandwidth speed. So that's what I'm going to demonstrate to you in a second. So let's just do some math. Let's say you have 12.5 million images in your database. And for every image, you extracted a feature vector. You extracted that feature vector, and it, as I told you earlier, it fits into 4 kilobyte space. So it's relatively small. Now, if you multiply the two together, 4K multiplied by 12.5 million, you get about 50 gigabytes of data. All right, and I claim that, that this command, right, select ID features where dot product, which scans the whole table, right? It has to go vector by vector and apply dot product to every vector, can go at the memory speed. And I'm going to demonstrate it to you right here on the laptop, on this laptop. So this is the laptop I have. It's one of the later models from Apple, but it's nothing special. It's just a laptop. So let me drop into a terminal and demonstrate this command. For simplicity, I'm just using just one constant is 0x and then all the a's. So 4 kilobytes worth of a's here for the binary multiplication. And then here I run a dot product command, and everything wraps into a SQL statement. Select count star, where I'm just counting how many those images are, where dot product, and at the end of this command is, well, I'm counting greater than 0, but you can say greater than 0.9. How many people know SQL? Okay, great. So everybody knows SQL. Everybody understands what this command does. Okay, yeah, so it goes row by row, applies dot product for every row, and checks if the scalar multiplication is greater than 0.9. And so we expect, because we just computed the size of this thing, we expect that this is 50 gigabytes, and if I'm telling the truth, that we're running this at the memory bandwidth speed, we'll run it for about a second. Does that make sense? Okay, let's try it. So this file is called b.sql. So I'm going to connect to MemSQL, and MemSQL just runs on this machine. I'm going to demonstrate it by connecting MySQL-u root-h0. By the way, MemSQL supports MySQL wire protocol, and the reason to that is we just don't want to be in the driver's business. So any driver is good enough, and MySQL exists for all the languages. So now I'm going to say source b.sql, and we just saw b.sql. Oh, use images. Change the database. Oh, 3 milliseconds. How's that possible? So we just talked about the fact that it's going to run for a full second. Do you guys have any idea why we're so much faster than that? Good question. Select count star from images. 12.5 million. So let's look at the schema of that table. Well, it's not even a binary, it's a binary. And binary means that, if the amount of data is small, it's going to be padded all the way to 4 kilobytes. So we actually did a full scan. We can run an explain here. An explain says, Columnstore scan, and then there's an aggregator, and then there's project. And then there's this gather operator, and gather operator exists in a distributed system. MemSQL is distributed, can run on many, many nodes. But in this particular case, it runs on one node. And I can prove that by running the command show leaves, and it says, well, it's just only one host. So it's a single node cluster. And yet, when we run this command, which it's impossible to cache the result, and we don't cache the result. So we do a full table scan. In this case, we run it even in 0.2 seconds. Any more ideas?
So hash, maybe you search it through a hash, not the actual data? Or what data is that going to show?
Well, I looked at the schema, right? The schema is binary, and then there's dot product, and for every dot product, we actually, ran this algorithm. So I told you that the amount of computation, because our dot product implementation is so fast, it is going to be trivial, and we're going to be limited by memory bandwidth. But who is familiar with the Columnstore technology? Yeah. So what are the properties of a Columnstore technology? Compression. That's a hint. Yeah. So because we have very, very strong compression, when we put 12.5 million rows into that table, they compress down very, very well. So in this particular case, because there's a lot of similarities in the data, we get 100x compression. And because it's 100x compression, we actually scan way less than 50 gigabytes. Having said that, we still performed all those computations. For every 12.5 million vectors, we did perform a dot product. But that's how fast the system goes. So now what does it mean? It means that in a matter of milliseconds, you can perform those visual searches. You can build a smartphone app that you point at a face, or you point at an object, or you point at a beautiful picture, and it will do something. Find similarities, or identify where you are located very, very quickly, and you don't need to have GPUs for that. That's kind of an interesting insight, where for training, you do need GPUs. But for scoring, For evaluating the model, you don't. Okay, let's continue. So just to drive that home, this is the architecture of this whole system that Thorn runs, as well as some of our customers who perform visual search. You start with a bunch of images. You use a machine learning framework. Thorn in particular uses Spark to parallelize their computations. And then they derive a model. Then they take that model, they take the last layer, which is vector.product, and they push that last dot product into MemSQL, which powers their application. And now they deploy that application as a service to border control, to police, to all those places who are actually finding missing kids, and we deliver them value in a matter of milliseconds. And this is the magic command, right? Selects ID from features where dot product, greater than whatever, some constant. So, so now let's, since we talked a bit about SIMD and we talked about vectorization and some of the performance improvements which you can get on a modern CPU, in fact on a CPU that powers most of the laptops, we don't just use SIMD for dot product. We use SIMD for all the SQL operations that you run as part of the SQL statement. So our query execution is quote unquote vectorized. And particularly you get tremendous benefits for analytical queries. And we're allowing you to take your analytical queries that process millions of rows and make them real time. So the way it works on the high level, Intel today supports AVX 512, and we implemented AVX2, which works on top of two 156-bit registers. And when you perform a trivial operation, like a filter or an addition or whatever expression that you might have that you need to evaluate as part of your SQL statement, you perform this operations in batches. So 256 bits worth of data, you can apply whatever operations you want in parallel for all 256 bits, not for just one integer, which is a 64-bit integer. Now, on top of it, because of that tremendous compression that we get when we implement Columnstore compression, you can put data into MemSQL tables and just use a few bits for every value. It's very, very typical for analytical workloads to store something like state. So, and state has only, 50 unique values. And now, how many bits you need to have to encode state, right? And you certainly need, so 1 byte is 256 bits, 256 up to 256, so divide by 2, divide by 2. So you only need 6 bits to encode each state. So now when we perform operations and computation running a SQL query, we never go from this 6 bits representing each state back to a string. And it gives you tremendous, just absolutely tremendous performance boosts. So you can get up to 100x improvement just on a single box. And MemSQL can run on 1,000 boxes. So that allows you to have all your, basically it gives you unlimited compute. So let me give you another demo. So we have another database here, and it's called Trades. And there's a table called Trade. And I'm going to do select count star from that table. So we have 225 million records in this table. Who here is familiar with MySQL? Who have ever put, hundreds of millions of records into MySQL? Anybody? How's that performing? So MemSQL comes with that custom chart, with scalability out of the box. If you put 225 million records into MySQL, first of all, it's going to take a long time. And second, when you run queries like this one, can't start from trace. Let's do some. I'm going to copy paste it from. From here. No. I have it somewhere. There we go. So what is this query? It says select stock symbol and then count star from the table trades. This is a particular hint from MemSQL, so ignore that. And then it says group by stock symbol, and then you order by this count value, and then limit 10. So give me top 10 most traded stocks. All right, and then you do this over 225 million records. So before I run this query, let's run another experiment. You guys know Python? Right, cool. So I love technical audiences. So let's run Python and run this command. For I in range 225 million, pass. How long do you think it's going to run? Any guesses? So I'm just going to run it. So this seems to me like oh, first of all, this is range. So let's do X range. Let's be smart about it. So for I in X range, 225 million, pass. Now this should be a little better. At least I hope it's going to be a little better. Okay, so it's about 10 seconds, right? So trust me, if you implement this thing in C, it's going to be much faster. But this is a naive implementation of this program. So now if we go back and run this command, now this command is optimized. So imagine you did everything you can possibly do, including vectorization, including operations on compressed data, including all these bitwise operations to run this command on this laptop as fast as possible. So I ran that, and I get 5 microseconds. And by the way, this thing is doing more stuff than the empty loop in Python. So it goes row by row, and a naive implementation would be creating a hash table and then populating that hash table, right? Because you need, for every stock symbol, you need to account how many times it's occurring in the table. So when we say we deliver on real-time analytics, we're extremely serious. Right? We're very, very serious. We take performance very, very seriously. There's years of innovation that went into a technology like this. But what it allows you to do, right, it allows you to process very large amounts of data at the memory bandwidth speed. And we support full SQL 99, and we can scale this system out. We support transactions. So MemSQL can really be the backbone of modern application, because we're giving you free compute. We're giving you free compute not only because we scale out, but because we also optimized the hell out of compute. So now that we looked at a couple demos, let me tell about the company, all right, and the technology. The way we kind of position the company is as a real-time data warehouse. So who is familiar with data warehouses, technologies like Redshift, BigQuery? Some people are. So data warehouses allows you to put all your data into one system at whatever scale, petabyte scale. The system is usually scalable, but it comes at a very important expense. You cannot run applications, real-time applications, on top of a data warehouse. because latencies are just not there. And the system usually does not support transactions. So data warehouses are usually data first, versus databases are, system of record first or transactions first, and then there's compute on top. So we give you the best of both worlds. This is an operational system. It runs some of the world's most demanding applications. So if you watch TV on Comcast, there's a system that powers that. There's a system that collects telemetry out of your set-top boxes. There's a system that runs billing for most important internet applications in the world. There is a system that runs at Uber, and you can find a lot of information about that with MemSQL if you type MemSQL and Uber on YouTube. Then the bottom line is we give you all that data at petabyte scale right at your fingertips. So you can build your applications, your big data applications, and do not sweat that the database is going to be the bottleneck. The database is not going to be the bottleneck. It's going to be something else. It's real-time and operational. So when people talk about real-time and then people talk about operational, those are pretty much interchangeable words when it comes to databases. So what does it mean exactly? Well, operational means you can put the system in production and have all sorts of manageability controls to run the system 24/7. That means backup, restore, failover, multiple copies of data, all that thing is there with MemSQL. And then real-time means that you can allow real-time ingest into the system. And it also means that you can have an application built against MemSQL, and the application usually runs a set of commands: insert, update, delete, and obviously select. Right? So it's not just read-only like a lot of data warehouses. You can build an interactive application that goes and modifies individual rows, that goes at very high concurrency, runs SQL statements. The system's compatible. It supports all sorts of ETL tools that allow it to push and pull data, push data into MemSQL and pull data out of MemSQL. It supports BI. You can take Tableau or Looker or MicroStrategy and attach a BI or reporting tool to MemSQL. And then it integrates with real-time infrastructure, so message buses. The one that we see all over the place now is Kafka. So who's familiar with Kafka? Some people here are. And that's just a scalable message bus. So for a scalable message bus, you need a scalable database where you can put data into. And that's what MemSQL gives you. And then on the deployment side is we support all sorts of cloud, including public clouds and on-premises clouds. Finally, we have a developer edition, so you can download it, play with the system. It's free. And also engage with us on the public Slack channel. There's always something going on the Slack channel, on technology enthusiasts, which I'm sure a bunch of them are in this room, have a lot of fun with the system. Gartner is a big believer in us, and they placed us as a challenger in the data warehousing quadrant. So whoever is familiar with Gartner and Magic Quadrants, they always have this Magic Quadrants where the lower left quadrant is niche players, the lower right quadrant is visionaries, but have low ability to execute. Then there are challengers. Those are usually you upgrade from visionary to a challenger when you beef up your ability to execute. And then eventually you are in the leaders quadrant. So here we cut out just the top two quadrants. The leaders on the right side, where we see Oracle and Teradata and Microsoft and IBM and AWS and SAP. And then on the left, you see a few other companies that are younger. And I want to point out that MemSQL is the only non-public company on this quadrant. So every other company here is public. HP's public, obviously Google's public, but Cloudera went public recently as well. Just to kind of drive the point home, is what people use with MemSQL is that is that ability to power modern applications. So we fit into AI and ML applications like a glove. People use pandas with MemSQL all the time, where MemSQL provides you the data backbone, and then you perform various operations either in pandas, in Python, or in Spark. And then the SQL part is something that we really nailed, right? We have the fastest SQL query processor on the planet. So kind of to sum it all up, the number one most important thing is that MemSQL allows you to build applications that have three modern requirements. One is fast ingest. The other one is low query latency. And I demonstrated to you right there where we sifted through 225 million records in just a few milliseconds. And then finally, it's high concurrency, right? So if you have, a large-scale internet application, or if you have an application that requires a lot of data manipulations in real time, where you do inserts, updates, and deletes, and then you expose this app to a lot of users, either on the internet or internally, there's just nothing better. And it gives you kind of a full set of system of record capabilities. There are a few things that we did recently. So I'm also proud to announce that we just shipped a new version of MemSQL, which is MemSQL 6. And we added what we call a control flow into the system. So whoever is familiar with databases knows that they're SQL, but there's all these storage procedures and user-defined functions. And usually new systems just don't have that. So if you take Cassandra, for example, it's a key value store, and there's not much you can do. Some people say, this is what you should do. You always should put the logic somewhere outside of the database so you don't pollute the database with storage procedures or user-defined functions. We actually believe in freedom. So if you want to do that, you do that. But if you want to put logic right there where the data lives, we give you that opportunity as well. You have a question? No? Okay. So now, where do we stand in terms of where's that boundary between being a database and being and fitting in the modern world of ML, AI, and you hear about something new every day. We believe that we need to provide world-class integrations with every single framework that's out there. And we have applications, they're actually quite common, where people use Spark and we enable very fast data interchange between MemSQL and Spark. Who's familiar with Spark? Yeah, some people. So Spark is a distributed compute framework, and we allow that framework to very efficiently grab data from the database and manipulate inside Spark, and when you're done, you throw it back in there. And then on top of it, there's all these new libraries starting from Spark MLlib. There's TensorFlow, Gleon, Caffe. The list goes on, and I guarantee you we're going to have more libraries coming out. We're not done with AI and machine learning. And our approach to each of those, which that are popular, is very, very strong integration. So again, MemSQL gives you fast access to data, large scale, and world-class SQL. And ML frameworks gives you either fast, large scale, or the two together. They give you kind of very cool general purpose compute libraries, and they're great for training. And MemSQL is great for taking the results of that training and operationalizing it. And we can do it on a very granular level, like we demonstrated with vector.product. Or we can enable things like scoring data as it goes as it ingests into the system. One of our big energy customer is streaming real-time data from drill bits, as they go through the ground. It's kind of very cool process because it's called directional drilling. You don't necessarily drill vertically. It actually goes miles and miles, kind of like this, through the ground. And those drill bits are extremely expensive. And the cost of not drilling is actually very, very high. So that particular customer streams data into MemSQL through Kafka, evaluates a machine learning model right there, right before ingesting, and MemSQL drives that ingestion. And we allow people to arrest a drill bit before it actually hits a problem. Saves them millions of dollars every time we save them from that type of situation. So that's all I wanted to talk about, and now would be a good time to ask a few questions.
So MemSQL supports the MySQL protocol, so it would be easy to write applications that put data into it. You mentioned sort of the HTAP or having, in our case, MicroStrategy or Informatica can easily connect to it.
Yeah, definitely.
For the same reason, because the protocol, we talked about operationalizing it. So how does it look similar or dissimilar, let's say, to MySQL in terms of backing it up and operationalizing it from a database
Yeah.
administrative point of view?
So from the backup standpoint, it's actually much better than MySQL. People back up MySQL either by shutting down the database and grabbing all the bin logs, or they run MySQL dump. And MySQL dump is a very invasive operation, if you think about it. We just support the backup command. We can run backup, and the operation is quote unquote online, meaning we don't take any locks. So we just grab that data and we put it right there. You can put it on an NFS volume. You can put it on S3. We integrate with enterprise backup solutions, so it's such as Rubrik and Cohesity. So it's super easy for you to run backups. Go ahead.
Another question. You showed an image search application. You talked a little bit about real-time drilling. Where else do you see real-time recognition for MemSQL?
Say what's
Where else do you see real-time applications?
Oh, it's a massive number of use cases. So for example, one of our customer in the music industry, they want to see how the ads perform, and they want to understand how the ad campaigns perform. That's one of the big internet radios. Every time you play a song, every time you play an ad, that certainly generates a bunch of events that they throw into MemSQL. From there, you need to automatically make decisions if you want to, for example, shut down this particular ad campaign. So why would you want to do it? Well, maybe you ran out of quota, or maybe the campaign is not performing, and the customer wants to automatically shut down the campaign if it's not performing. But in order to understand how campaign performs, it's a big data problem. So in the past, they had a 24-hour window until they actually know how well campaigns perform. Because they would run Hadoop jobs, and would go take these Hadoop jobs and populate them in Cassandra, and they can go to Cassandra, and now they know how that campaign performed yesterday. With MemSQL, they just stream data right there into MemSQL, and they know how the campaign performs now. And that's a big deal for their customers. And because they make their customers' lives better, they drive more value. So now you can just query MemSQL and understand the click-through rate of their campaigns down to a second. Yeah, go ahead.
So, unfortunately, I missed the first part of the presentation. Probably you told a bit more about your persistence capabilities. Some time ago, I read that you support the persistence in a different way for Columnstore and Columnstore.
Yeah. Let's rewind a little bit. I didn't actually talk about it in this presentation, But MemSQL supports two what we call access methods. Or if you think about them as table types. Table types can be row store and column store. And so a row store table pinned it into memory. And the reason to that is people use row stores for very high frequency updates. We can drive millions of updates per second through row stores. And people use column stores for more analytical queries. And you can only achieve that level of performance for analytical queries on column stores. So it's not necessarily, so the interesting fact is it's not necessarily row stores are faster than column stores. Even though they're pinned in memory and column stores are not, they live on disk, but they're cached into memory. Aggregations can be implemented much faster on column stores. Now, the persistent layer is the same. Doesn't matter where you put data, row stores or column stores, we maintain a transaction log. And if the system is restarted, whatever made it into MemSQL stays in MemSQL. So we give, system of record capabilities with a couple caveats, and we can talk offline what those caveats exactly are. And then from where the data actually lives, row store data is stored on disk, but it always has to be pinned in memory. And then column store data lives on disk, and it's only the working set is being cached.
Then is my understanding correct that if, for instance, I use the column store and have some data, I can have a subset of the data in memory,
Mm-hmm.
the full set on disk, and all the analytical queries I'm going to run, they can process the data that is stored in both tiers, right?
Mm-hmm.
But as for raw store, I have to preload all the data from
Yeah. Yeah, so because column store data is compressed, and so there are a lot of people with a computer science background, inserting in the middle of something that's compressed, it's kind of tricky, right? And so what we do is we have this, when we insert somewhere in the middle, we have a small in-memory buffer. So we insert there, and that buffer is in a row store format. And then as this buffer grows, we trickle down that data into a column store. So that's pretty cool, and we support updates and deletes. So we delete on something that's compressed, instead of decompressing and finding that thing and recompressing back, we just mark it as deleted and then reinsert into the same in-memory buffer. So that allows you to run actually quite a lot of concurrent updates and deletes against even column stores. And that's what we mean by real time. Because real time allows you to run this type of operations at high concurrency. Go ahead.
So I had a question about the dot product function that you guys implement.
Mm-hmm.
This is something that's only available in MemSQL. Do you have more of these specialized instructions which are?
Yeah, so we have dot product and we have Euclidean distance, and I think we have dot sum or dot subtract. That's it at the moment, and then we will be beefing it up.
Provide an API so people can.
Yeah, you can write your own in our language. Now, there's a bit of a caveat here. We implemented dot product in C, and so we vectorized it. So we used all these SIMD instructions to give you the fastest possible way of computing that stuff. When you write it in our language does not support SIMD. If the compiler, but we compile everything, so if the compiler automatically injects SIMD, we use LLVM, then you're in luck. Now, for this one, when that we wrote in C, we actually wrote it in assembly.
I like the way you define the word luck.
Right. Any more questions? Go ahead.
Okay, the question about machine learning capabilities. I didn't get. Imagine that we trained the model using some third-party framework like TensorFlow,
Mm-hmm.
and then it was deployed on top of MemSQL.
Mm-hmm.
How do I execute my deployed models? Do I need to use SQL?
So either score in your application, and then whatever the result of that score, it persists in a database, which is going to be the way that's going to work with MemSQL or any other database. Or we have a particular feature called pipelines. And pipelines are built for ingestion, and they allow you to connect to a particular data stream, or should it be a dynamic stream like Kafka, or should it be a static set of data such as S3 or just a file system? And then you load that data, and you can inject your own code in the loading. So what it saves you, from the need to have an application server, right? Because now it's kind of very, very straightforward. Here's my data, here's and it's coming, right? It's coming through Kafka. Here's my database system. This is, and then you type create pipeline. Let me show you the system, the syntax. To do create pipeline in MemSQL. Still connected to my phone. So you say create pipeline, load data Kafka, and then for those who are familiar with the MySQL load data command, that's all that stuff. Load, and you can replace data, or you can append to that data. And you can also inject what we call a transform. Yeah, with transform. And in that transform part, you can specify your own code written in Python, Java, whatever you want. And people actually use it quite a lot. They use it, this is the technology that they use at this big oil and gas customer, where the model is actually written, you wouldn't believe it, but it's written in SAS. And then the custom code that they deployed there just runs a SAS module that performs the scoring. Any more questions? Go ahead.
You mentioned in the developer license it was unlimited. That's kind of unusual. What restrictions do you have?
No security and high availability. So you can create a root password. You can set a root password for the system, so it's not going to be wide open. But you cannot create users or groups, and you do not have high availability.
But there's no restrictions on where you can use it?
No, there's no restrictions on scale. You cannot use it in production though, legally.
That's
Yeah.
Thank you.
Yep. That's it. Thanks so much.